We're continuing with our first topic, and if you remember from last time, we were discussing the homogeneity of an equation, and I did a couple of questions. Let's do another one, and just so you can have a quick recap, and then we can move forward from there. So let's say I give you a question in which I say that capital T is equals to k square root of ml cube over e. Now, what you must understand is that t is time and m is mass, l is length, and e is a quantity which is called Young modulus, something which you will do later on in your course for the AS. And they're asking you in part 1 to find the base units of e, and in the second question or the second part they're asking you to find the base units of k. So that's your question. Now what you need to understand is that E, as you can see, it's clearly a physical quantity, a Young modulus. वो question में बहुत clearly कहता है that K is a constant. Now you must remember this and note it down somewhere that constants may or may not have units. It depends on the question. So like for example, in this particular question, this constant K, we don't know whether it has a unit or not. The question will tell you whether the constant has a unit or not. Now your question अब आपके ज़हन में आएगा कि इसका what's the significance of this, इसका मतलब क्या है? इसका मतलब ये है कि अगर उसने लिख दिया k कांस्टेंट है और मुझे k के ये बेस यूनिट्स चाहिए, इसका मतलब ये है कि in this equation k cannot be ignored. But if I said k is a constant with no units, तो पहली बात है मैं आपसे ये सवाल कभी पूछता ही ना कि k के यूनिट्स बताएं, क्योंकि k के यूनिट्स होते ही ना. और अगर ये इक्वेशन लिखी होती तो आप k को बहुत कन्वीनियंटली इग्नोर कर देते. You could have just rubbed it off and said that this does not matter. We'll do a question in which a constant will have no units, just to add to your knowledge. So let's stick to this question for now, that you have two quantities E and K, and I want you to find the base units of E and I want you to find the base units of K. Now, a lot of kids in the AS have this confusion. वो करते क्या हैं, वो फॉरन टाइम का यूनिट डालते हैं सेकंड, K का यूनिट पता नहीं होता, स्क्वायर रूट लगाते हैं, M का यूनिट kg लिख देते हैं, L का यूनिट m लिख देते हैं और m क्यूब कर देते हैं और अंडर रूट लगाते हैं. Now you suddenly have two unknowns in one equation and then they get stuck and they say कि ये तो सॉल्व ही नहीं होगा, तो क्वेश्चन ही गलत है. क्वेश्चन गलत नहीं है, आपकी अप्रोच गलत है. Whenever you find out a quantity which you already know, you should know this quantity from your AS lectures. E, Young modulus, has a formula, and that formula is stress over strain. So E के जो units हैं वो हैं E का जो formula है, sorry, that is stress over strain. Let me write it down over here. So capital E has units stress over strain. Now what is stress and what are the units of stress? Stress is force over area and strain is extension over the original length. Now you must have recognized that the stress in this equation has the same flavor as pressure. So इसके अंदर pressure के base units डाले जाएंगे. Force का unit था ma, force का formula था ma और area को area लिख रहे थे. Now m, mass मतलब you will write kgs, acceleration you will write ms minus 2, and area you will write meter square. So you end up getting kg m minus 1 s minus 2. Next, when you look at strain is extension over original length. So when you're looking at extension over original length, extension is also a length is also a length. So extension की यूनिट सेंटीमीटर होंगे और लेंथ की यूनिट भी सेंटीमीटर होंगे. सेंटीमीटर कट जाएगा और यहाँ पे 1 आ जाएगा. ये जिस तरह मैंने बोला एक्सटेंशन हैज़ यूनिट लेंथ और लेंथ की यूनिट भी लेंथ है, इससे मुझे वो बिलावल भुट्टो वाली बात याद आ गई कि वो बारिश कम होती है तो कम पानी आता है, बारिश ज़्यादा होती है तो ज़्यादा पानी आता है. इट्स जस्ट द सेम थिंग कि मैं कह रहा हूँ लेंथ इज़ ऑल्सो अ लेंथ. So what you must understand is कि extension की unit centimeter डालो, length की unit भी centimeter होंगे, extension की unit meter डालो, तो length की unit meter होंगे. Basically, what I mean to say is that this units for strain will be 1. 1 का मतलब क्या होता है? 1 means that it has no units. Now, pulling back to this equation of stress then, so इसका मतलब ये हो गया कि स्ट्रेस की जगह आपने डाल दिया वही जो आपने निकाला था के जी एम माइनस वन एस माइनस टू. स्ट्रेन की जगह आपने डाल दिया 1. सो यंग मॉडल्स के यूनिट आ गए के जी एम माइनस वन एस माइनस टू, द सेम यूनिट्स एज स्ट्रेस. सो ई इज सॉल्व्ड, दैट्स पार्ट 1. E has units kg m minus 1 s minus 2. Now, the second part of the question was find the base units of k. So for that, you need to make sure that you have this E written in front. And let's pull back our actual equation. Our actual equation was time period is equals to k times square root of ml cube over E. Now, whenever you get an under root, I always tell my students that, you know, it's better that you square both sides. It'll make your life easier. But if you don't want to square it, it's okay. We can even solve without the square. But let me square it for you. So, when you square both sides, you will get t square is equals to k square bracket ml cube over e bracket shut. Do not forget to put the square on k. A lot of kids forget this square. Do not forget it. Now, let's substitute the units. So t square का यूनिट s square, k square हमें निकालना है, m mass था kg, l cube is meter cube, and now you have the units of e, and e was kg m minus 1 s minus 2, so you can substitute that unit over here and you can write kg m minus 1 s minus 2 bracket shut and try simplifying it. So kg gets cancelled. थोड़ा सा बेसिक इंडिसेस भी है इसमें कि व्हेन यू सिंप्लीफाई इट यू विल गेट एस स्क्वायर इज इक्वल्स टू के स्क्वायर ब्रैकेट m की पावर माइनस 1 ऊपर जाएगी, इट विल बिकम m4, s की पावर माइनस 2 ऊपर जाएगी, इट विल बिकम s स्क्वायर एंड ब्रैकेट शट. नाउ ऑन बोथ साइड्स s स्क्वायर एंड s स्क्वायर विल गेट कैंसल्ड, सो यू एंड अप गेटिंग k स्क्वायर इज इक्वल्स टू 1 ओवर m की पावर 4. m की पावर 4 आपको इस साइड पे नज़र आ रहा था. व्हेन यू टेक इट टू दिस साइड, यहाँ पे 1 है, सो 1 ओवर m की पावर 4 बन जाएगा. नाउ इफ I drag it here and now you simplify it, you can write this as k square is equals to m की power minus 4 and k would be m की power minus 2. I hope you understood that question. Now, as I promised, let's do another question in which a constant does not have any units. For example, I give you a question like, this one. So question mark is equals to square root of gamma p over rho. Now, gamma is a constant with no units. Question में लिखा हुआ है. Alright. P stands for pressure and rho stands for density. Now, I want you to pause the video, and before you pause the video, listen to me very carefully. Gamma has no units, so you can ignore gamma. Do not ignore the under root, please. Under root, power, square हो, under root हो, cube root हो, cube हो, power 4 हो, कोई भी power कभी भी ignore नहीं करनी. Because if you ignore it, the question will go wrong, even if you're doing a simple base unit analysis. So, ignore gamma, put the unit of pressure in P, and put the unit of density in rho, simplify them, take the under root. You will need the under root. आपको खुद समझ आ जाएगी under root के बगैर काम नहीं होगा. And when you simplify, it will come out into a quantity which you've seen before. Base units की अच्छी बात ये होती है that whenever you're solving them, you will always end up with something which is very, very familiar, something which you've seen before. So, now solve the question. I hope you've solved it, and your answer to the question mark should have been meter per second. So you identified the quantity as speed. Now, let's say you weren't able to do it, not a problem. Let's have a look. So if you weren't able to do it, तो आपने gamma को इग्नोर तो किया होगा. Like I told you, आपने प्रेशर की जगह प्रेशर की यूनिट्स डाले होंगे और आपने रो की जगह रो की यूनिट्स डाले होंगे. Let me tell you another way. आपने अगर आपका आंसर नहीं आया, that means that you have either put the wrong units for pressure or you have put the wrong units for density. Now the units for pressure was force over area. If you remember, abhi piche nikala hai aapne, kg m-1 s minus 2. That was the unit for pressure. And the unit for density is kilogram per meter cube, kg m-3. So you need to substitute those units over there, and you will get under root of kg m-1 s minus 2 divided by kg m-3. Kg will get cancelled, m-3 goes up. It becomes under root m squared s minus 2. And guess what? Under root laga hua hai dono ke upar. Now you should be able to do it in one step, but if you're not, have a look. Isko aap aleda bhi kar sakte ho. Under root m square, under root s minus 2. Ye 2 under root se cancel hoga. So you're left with ms minus 1. Ye minus mat bhul jana yahan pe. ms minus 1. So what was this quantity? This quantity was speed. Brilliant. Another way that you could have done this question and not gone through all of this hassle was the same question given to you. Question mark is equals to square root of gamma p over rho. I told you gamma is a constant, so ignore. So your question then becomes question mark is equals to square root of p over rho. Now I'm very sure that in your O levels you've done this equation, which is pressure is equals to rho gh. If you substitute that over here, you will get under root rho gh over rho. Bhai, logically, if everything is right, you will always get the right answer. So never ever compromise on the logic. Density and density will get cancelled. So you are left with under root gh. Now under root gh, what is g? G is acceleration. What is h? H is height. So acceleration ka unit aa gaya meter per second square. Height ka unit m. So you'll get under root m squared s minus 2. Again, you end up with the same answer as earlier. If you remember, you got this. So if you can see, you got under root m squared s minus 2 over here, and I'm getting the same thing over here. So wo cut ke ban jayega ms minus 1, and that's exactly what we wanted, that this answer should be ms minus 1. So the quantity that you were looking for was speed. Brilliant. Now, we will quickly go through a table of prefixes, or the so-called prefix table. Prefixes are words or letters which you put before a word in English. So in physics, a prefix table would mean capital T, tera, then capital G, giga, then capital M, mega, then small k, kilo, and then you have deci, small d, centi, small c, milli, small m, and I'm done with my space. So U or micro, and then you have nano, small n, and you have pico, small p. Now, all of these prefixes have their values. So tera has a value of 10 to the power 12, giga has a power of 10 is power 9, mega has a power of 10 is power 6, kilo has a power 10 is power 3, deci 10 minus 1, centi 10 minus 2, milli 10 minus 3, micro 10 minus 6, nano 10 minus 9, and pico 10 minus 12. The list actually goes this way and this way. Dono jagah pe list bahut lambi hai, but in your syllabus we will remain confined to these prefixes over here. One thing I always tell, please pronounce this correctly. This is not tera, this is tera, and C is centi, centi with a C, not with an S. Okay. Now, if you look closely, ye kilo, mega, giga, tera, you've heard these words before. Kilobytes, megabytes, gigabytes, terabytes, centimeter, millimeter, micrometer, nanometer. You've heard these words. So that tells you that when wo word aata hai, micrometer, so you should be able to tell that, okay, it's measuring to the 10 to the power of minus 6. Or when you heard the word terabyte, it means 10 is to the power 12 bytes. Or if you hear the word GB, it means 10 is to the power 9 bytes. So You've heard these terms before, but you don't know the values of them. Now you're supposed to memorize their values. Please do not forget them. I'm going to move on to a very, very important topic of the different instruments that you will be getting in your physics lab, and every instrument's precision, and then every instrument's uncertainty. Now, the common instruments that you get, for example, in the lab, one is a meter rule. Now, when you talk of a meter rule, your question should be, what is precision? Precision hota kya hai? So, precision is the least count of that instrument. The least count of any instrument is its precision. So, for example, for a meter rule, if you want to look at what the least count is, you should simply have a look at the meter rule and say, well, meter rule ka sabse chota reading mujhe kya nazar aa raha hai? And your answer would be the smallest reading that you can see for a meter rule is 0.1 centimeters. Let's do precisions first, and then we'll head on to their uncertainties. So that's meter rule. Then you also have a protractor in the lab. Now, when you talk of a protractor in the lab, a protractor has a precision or a so-called least count of 1 degree. And then you have thermometers in the lab. Thermometers have a least count of 1 degree Celsius. That's the smallest reading. Again, if you ever forget these precisions, that's fine, because you will get these instruments in the lab. So you should know how to look at the precision. Precision is the smallest reading of that instrument. Now, what you must remember is that every instrument that you take will have an error or will have an uncertainty in it. No reading can be perfect. So, how do you calculate uncertainty? Uncertainty is always 50% of the least count or the precision. So, for example, for a meter rule, it will be 0.05 cm, and uncertainty ko hamesha plus or minus साथ लिखते हैं. For a protractor, it will be plus minus 0.5 degrees, and for a thermometer, it will be plus minus 0.5 degrees Celsius. So this way you can get the precision and the uncertainty. Precision aa jayegi directly from the instrument, and uncertainty you'll simply do 50% of the least count. Only for stopwatches, for example, if you talk of a stopwatch, and if you've used it in the lab, a stopwatch measures to an accuracy of 0.01 second, at least the ones that we use in the lab. 0.01 second, unka sabse chota number hota hai. Now, for a stopwatch, you cannot use the same logic. The reason is it's a digital instrument. So what do? You use something which we call the half range method. And half range method, we will definitely discuss later when I discuss how to do the lab. But for now, I'm just telling you that you will be using the half range method to calculate the uncertainty and no other method. Great. Moving on. Another very important topic of precision and accuracy. Now, when you talk of precision and accuracy, precision दो चीज़ों की हो सकती है. Precision reading की भी हो सकती है, precision instrument की भी हो सकती है. Precision reading का मतलब है precision एक experiment की भी हो सकती है, but precision एक instrument की. Accuracy is that of an experiment or a reading. Now, the two terms are used very inconveniently, and a lot of kids from my O levels tend to confuse the two statements. कभी उनसे पूछें कि जी is the reading more accurate, they'll say more precise. If you ask you is it more precise, they'll say more accurate, because they really don't understand the meaning. Now, the meaning of precision is, please note this down, that precision measures how closely two or more values are to each other. Precision measures how closely two or more values agree with each other, or how close two values are to each other. So precision is basically the closeness of readings. That is what precision is. If you ask me in a single word, what is precision? Precision is the closeness of your readings. But remember that this definition only applies to experiments. Precision of an instrument, I've already told you, this is the least count of that instrument. So do not confuse. Your paper में सवाल आ जाएगा, वो कहेगा जी what is the precision of a vernier caliper, पता चलेगा आप लिख रहे हैं the closeness of readings. Obviously that's the wrong answer. The precision of a vernier caliper is not the closeness of its reading, it's the least count of that instrument. All right, so precision should be clear to you. Now, what is accuracy? Please note, accuracy is how close a value is to the actual value. How close a measured value is to the actual value. Measured value और actual value कितने करीब है? That is what accuracy is. और experiment की ही होती है, ये instrument की नहीं होती. So never say an instrument is accurate. I agree that an instrument can be precise, but an instrument cannot be accurate because accuracy depends on you. How close the value is to the actual value, that depends on you, not the instrument. Actually, that brings up a very interesting point, and I want to tell you. मैंने कहा कि instruments की precision हो सकती है, but instruments की accuracy नहीं हो सकती. इसका क्या मतलब है? Let's have a look, and let's see how we evolved. So when we started off, शुरू में हमारे पास होते थे meter rules. All right. So meter rules used to have a precision, as I just told you earlier, of 0.1 cm. Later on came vernier calipers. When vernier calipers came out, they had a precision of 0.01 cm. Can you see suddenly the decimal places have gone up? That means vernier calipers measure more precisely. और उसके बाद क्या हुआ? उसके बाद आ गए micrometers. Now when micrometers came into the picture, then the precision went up to 0.001 cm, even better. So you can clearly see that as you go down, the number of decimal places are increasing, and as a result, your precision is increasing. So अगर precision नीचे की तरफ increase कर रही है, और मुझे एक बंदा एक question में पूछता हूँ that I measured a length, all right, I measured a length from a meter rule, and that length was let me make a meter rule for you, and I put this object, मुझे इसकी length measure करनी थी. All right, now this edge over here is at the 3 mark, and this edge over here is at the 5 mark on the meter rule. And I asked you, what is the length? So बड़ा simple सवाल है. What is length? Length is 5 minus 3. Now somebody writes 5 minus 3, 2 centimeters. This is absolute nonsense. Why? Because अगर आपने meter rule use किया है, I do not understand how do you get an exact number. What you should have written was 2.0 centimeter. Please try to relate this with the precision. Precision में देखो कितने decimal place नजर आ रहे हैं, मेरी reading में भी उतने decimal place होने चाहिए. नहीं जी, आप में से somebody feels very excited about this and next day goes and says, well, you know what, I used a meter rule and sir was telling us to be precise, and here we go, I am now super precise. मैंने meter rule से reading 2.00 centimeter आ गई. This kid is mad. The reason is that my question would be, when you took this reading, did you use a meter rule or did you end up using a vernier caliper? Look at vernier caliper. You've got 2 decimal places in the centimeter, and over here also got 2 decimal places in centimeter. How is this reading possible with a meter rule? So I hope you get my point. हमेशा याद रखो, whenever you're taking a reading with any instrument, the way you write a reading tells us what instrument you've used. So be very careful. The examiner is very smart and the teachers are also very smart. They don't need to see you to know what apparatus you're using. They will know by the way you write. At least I can tell with very great clarity when a student writes something, I know exactly what's going on in his mind, and I know that this kid has gone off track completely, and this kid has also gone off track completely. So please, you're all great students. I don't want you to getting any off track ideas. All right, so the precision of an instrument is clear to you. Let's bring back our original. So I was discussing precision and accuracy. We have right now discussed the precision of an instrument in detail. I have already told you that this precision means how close your values are, and the accuracy means how close you are to the actual value. Now, to give you an example of this and this, experiments are related, how can you get a question? Let me pull up another new page and let me give you a question. So I say that I give you 4 graphs, all right? This is graph number 1. This represents the true value जो आनी चाहिए थी, all right? Now on the y-axis over here, you have the readings, the number of readings, and on the x-axis over here, you have the measured values, all right? So on the y-axis, you've got the readings, and on the number of readings, and on the x-axis, you've got measured values. And let's say this is a curve that we get. It's called a bell curve. If you don't understand what this curve means, it's fine, but let me explain it. This curve basically tells you कि आपने ये वाली एक measured value आपकी. This curve tells you that how many times has this measured value occurred, how many number of times the measured value has occurred. So, for example, you pick up this value, this measured value has occurred this many times. If you pick up this value has occurred this many times. So, this curve basically tells how many times a value is coming in your particular experiment. I hope you get the idea. So, you've got one curve like this, and then you have another curve which looks like this, n on the y-axis and measured values on the x-axis, and now you end up getting a flat curve like this, and of course your true value is also here. Now this is your true value. The question arises, comparing both of them, which is precise and which is accurate. Now if you go back to the definitions, precision was how close your values are to each other. So look at this. This is the spread. And in this case, this is the spread. The values are very far, the values are very close. So you will say definitely this is more precise, this is not precise. What was accuracy? Accuracy has nothing to do with the spread. Please never confuse accuracy with the spread. Accuracy is your true value coming in your readings? Yes, it is. Accuracy, इधर भी देखें, true value is coming in your readings. Is it coming in your curve? Yes. That means while you were taking your readings, the true value came. While you were taking your readings, your true value came. So both of these experiments are accurate. If your question is, फिर accurate कब नहीं होगा? तो वो तब नहीं होगा if the graph looks like this. So if this, but in fact, why don't you try it? I want you to make a graph in which I have a lot of precision, but I don't have accuracy. Pause the video and make it and then play it again. I hope that you have made this n versus measured value graph like this, that the true value is somewhere here and you have a lot of precision, which means the spread is very, very small. This spread is very, very small, but the true value is not coming inside your curve. So that means it's precise, but it's not accurate. Now, don't get bogged up about the height of the curve. That's fine. अगर आपने height छोटी बनाई है, as long as the spread is small, we are very happy. All right, now let's link this concept of accuracy and precision with something more theoretical but very practical, and that is systematic and random errors. Systematic and random errors. Now, what are systematic errors? Systematic errors are basically one-sided errors. One-sided का मतलब अभी आपको थोड़ी देर बताएंगे. They are one-sided errors and they occur because of a reading that is always above. Reading is always above or below the actual value or the true value, या जो असल value है. So they are one-sided because the reading is always above or below. Focus on the word or. And on the other hand, random errors are two-sided errors, and they occur because the reading is either above or below the actual value or the true value. So random errors are one-sided because they cause the reading to be either above or below, and random errors are two-sided because they cause the reading to be either above or below. So यहाँ पर ऊपर भी जाएगा और नीचे भी जाएगा, यहाँ पर हमेशा या ऊपर रहेगा या नीचे रहेगा. Try to understand. So random errors can be two-sided and systematic errors can be one-sided. Let me give you an example to clarify this statement. Now, if you think of it this way, that you go to Gourmet or any bakery and you take up some biscuits and you put them on this machine. This machine is already showing you a reading of 0.1 grams by default without putting anything on it. Now, every time you put something on it, it will give you a value which is 0.1 grams ahead of the actual value. So actual value जो भी है उसमें 0.1 gram plus होके आ रहा है. This is what a systematic error is. Now, that is what we mean that the actual value and the true value will always be different, and the actual value and the true value will always have a one-sided error. मतलब either it will be above, इस machine में for example you will always be above. If you take another machine and let's say the same bakery has another machine which is showing minus 0.1 grams and you put something on it, that means whatever the actual reading is उसमें से 0.1 gram हमेशा कम मिलेगा. So either you are always above or you are always below. So always का word बहुत ज़रूरी है. या आप नीचे हो या आप ऊपर हो, दोनों नहीं हो सकते. So if both cannot happen simultaneously, because this is another machine, this is machine 1 and this is machine 2. Both cannot occur at the same time to the same machine, so that's why it's called systematic. Now, what would we define as a random error then? So random error may, if you think of it, think about it. Say you have a protractor and that protractor has a reading of 25 degrees over here and a reading of 26 degrees over here. Ab zahir hai, between these two readings there can be no reading because you know that the least count of a protractor is 1 degree. Now, you were measuring an angle, and how many times has this happened in your life that the reading is coming in between the two? So it's not on 25, it's not on 26, it is between 25 and 26. Now, when this happens, you will have an argument. Somebody will say this is 25.1, somebody will say this is 25.3. This randomness in your reading is called a random error. So random error की common source होती है when a reading lies between the graduations. इसको कहते हैं graduations. These lines that are marked on the scale or on the protractor or on the instrument, they're called graduations. So if a reading lies between the graduations, that is a source of the random errors for you. Another example of random error would be if, let's say, you are taking readings from a liquid and the thermometer reading sometimes goes up, sometimes it goes down. So it keeps on fluctuating, kabhi niche, kabhi upar. You will never ever get to one value because the reading is fluctuating. So whenever the reading is fluctuating, it is also a source of random errors, because when you say the word fluctuation, it means you can go both up and down. I hope random and systematic errors are clear to you. And now to wrap up the lecture, how do you relate all of these constructs together? So हमने पढ़ा random error, हमने पढ़ा systematic error, हमने पढ़ा precision, और हमने पढ़ा accuracy. Now you need to combine all of your concepts and let's see if you understand them correctly or not. Random errors are fluctuation errors. Systematic errors are one-sided errors. मुझे ये बताओ that if you are making random errors in a reading, which is due to fluctuation. कभी reading ऊपर जा रही है, कभी reading नीचे जा रही है, कभी बहुत ऊपर जा रही है, कभी बहुत नीचे जा रही है. What do you think this will affect? Have a look at the definition of precision and accuracy. Precision was how close the values are to each other. Accuracy was how close you are to the actual value. So random error means that the value is going very, very down and very, very up. So you see big fluctuations. As a result, I hope that the thought that comes to your head that random errors affect the precision of a reading. And what was systematic error? Systematic error was one-sided. One-sided का मतलब है जैसा पहले कहा था, your reading is always 0.1 gram above the actual value. So you're always differing from the actual value. You won't ever get to the actual value. So systematic errors end up affecting the accuracy of your measurement. All right. I hope you had a good understanding of the lecture. I'll see you in the next class. Best of luck. Keep sharing the videos. And in the next lecture, we will be discussing the percentage errors and absolute errors. All right, guys. Have a great day. Thanks.